Something impossible is happening beyond the orbit of Mars. A comet from another star system is exhaling torrents of water into the cold vacuum, singing a song that shouldn't exist this far from any sun. Scientists call it Three-Eye Atlas, an interstellar vagabond that defies every rule our own comets obey. It glows green, leaks nickel without iron, and behaves as if it remembers the chemistry of an older galaxy. Yet behind the equations and telescopes lies a deeper question. What does it mean when something lifeless acts alive? Tonight we follow its trail through mystery, science, and wonder, to see what this cosmic visitor might be trying to tell us. Before we dive into the heart of this journey, stay with me until the end. What you'll hear tonight connects science, mystery, and meaning in ways that few stories can. If you've ever looked up at the night sky and felt that quiet pull of curiosity, this one's for you. To keep discoveries like this alive, I need your help. Tap like, hit subscribe, and share this episode with someone who still believes the universe has secrets left to tell. Post it on X, drop it into a Facebook group, or share it on Reddit wherever you gather with the dreamers and the skeptics alike. Every share brings more eyes to the sky, more voices into the conversation, and keeps this community searching for truth beyond headlines and noise. And to everyone who's been here from the beginning, thank you. Your comments, your theories, your simple "I'm listening" messages mean the world. Together we're building something rare, a space where wonder still matters. Now settle in, because what comes next will take us far beyond Earth, past everything we thought we knew, and into the quiet heartbeat of the stars themselves. Imagine drifting in the silent dark beyond Mars, where sunlight fades into a whisper and everything frozen stays that way forever. Out there, in a region where ice is supposed to sleep for eternity, something stirs. It exhales. A distant comet, newly arrived from another star system, is releasing 40 kilograms of water every second into the vacuum, a steady, ghostly breath in a place too cold for such motion. Astronomers named it Three-Eye Atlas, but the name feels too ordinary for what it is. It doesn't follow the laws of our solar system. It ignores the boundaries drawn by physics textbooks. It acts alive. The first clue came from SWIFT, a space telescope built to hunt the brief flashes of gamma rays that mark the deaths of massive stars. When SWIFT turned its ultraviolet sensors toward this strange visitor, it saw something that should have been impossible. A glowing shroud of hydroxyl molecules, tiny fragments created when sunlight tears water apart. The presence of hydroxyl means water had been there moments before, vaporized by light in a region where no comet should even stir. Calculations followed, and the results made the entire astronomy community blink twice. At a distance of 3.5 astronomical units, more than 3 times farther from the Sun than Earth, the comet was losing over 1 trillion water molecules per second, about 40 kilograms each second, enough to fill a bathtub every moment in the deep cold. Our local comets don't behave that way. In these outer reaches they stay quiet, locked in ice until they drift closer to warmth. The sun's energy out here is too faint to drive sublimation, the process that turns ice directly into vapor. But Atlas seems to have skipped the memo. It roars where others whisper. Scientists compared it with the 2 other known interstellar visitors. The first, the cigar-shaped traveller called Oumuamua, was bone dry, a mute stone that spun through our system without shedding a single puff of gas. The second, 2I Borisov, did produce a cloud of vapor, but nothing unusual. It followed the normal rhythm of our own comets. Atlas is different. It's performing a chemical symphony that no one expected to hear. If it was simply another lump of ice and dust, the story would end there, but this one refuses to play by the rules. Somewhere within that spinning mass, a mechanism is at work, releasing water with the persistence of a living heartbeat. The question that echoes through observatories and late-night research meetings is simple. How? What invisible engine powers this comet's impossible breathing? Some scientists whisper about exotic ices materials that vaporize at temperatures far lower than water. Others imagine internal heat preserved from its birth billions of years ago, a faint ember that never completely cooled. Perhaps sunlight is being funneled by its rotation, focusing energy into hidden pockets of volatile material. Or maybe, and this possibility keeps the curious awake at night, it's chemistry we've never seen before, a reaction unknown in our laboratories, but commonplace in a foreign star's backyard. The water is only part of the riddle. Spectral readings reveal traces of cyanide, nickel, and carbon dioxide, all in concentrations that don't match any pattern we know. Each new line in the spectrum adds another question instead of an answer. When light from the comet is split into its component colours, it paints a picture of a place that shouldn't exist. Materials glowing at unexpected wavelengths, suggesting processes that defy our models of heat and composition. It's as if Atlas comes from a universe with slightly different rules, where chemistry followed a different recipe, and now it's here, streaking through our sky, giving us a fleeting chance to look through that crack in the cosmic order. For the astronomers who study it, Atlas isn't merely an object, it's a message. A whisper from another system saying, "The universe is larger than you imagine. Every telescope capable of seeing ultraviolet, infrared, or visible light is now trained on it. Spectroscopy, photometry, polarization, every instrument hums in unison, trying to decode the signature of something both familiar and alien. To call it exciting would be an understatement. It's unsettling. It hints that the physics we rely on might not be universal after all, that in another corner of the galaxy, conditions shaped matter into something we barely understand. The most haunting idea is that this comet might not be a mere oddball. Maybe it's typical of its kind, one of countless interstellar fragments crossing between stars, each with its own strange chemistry. If that's true, then our solar system is the anomaly, not Atlas. Its behavior might be the rule elsewhere. Perhaps in distant systems, comets like this are common breathing water into the dark without sunlight, carrying the elements of life across the void. For now, 3i Atlas streaks silently through our telescopes, a visitor from a world with unfamiliar physics. Its vapor trail is a line of punctuation in the cosmic story, a reminder that not everything out there has read our manual. Somewhere, in the chill beyond Mars, a rock is exhaling. Every puff of vapor carries atoms older than our sun, molecules forged around a different star. To watch it is to glimpse the possibility that nature's creativity is far wilder than we've dared to believe. The universe, it seems, is still capable of surprising us, and perhaps, in its own quiet way, of speaking. The discovery didn't stop with water. As scientists examined the light spectrum emitted by 3i Atlas, a new enigma appeared, a glimmer of metallic fingerprints that didn't belong together. There it was, clear as day, a spectral line showing nickel, one of the heavy metals formed in supernovae, yet its usual companion, iron, was conspicuously missing. In the universe, nickel and iron are cosmic twins. They are born side by side in the nuclear furnaces of exploding stars, locked in near-equal ratios throughout meteors, planets, and stellar remnants. Their dance has been so consistent across billions of years that seeing one without the other feels like hearing a melody missing half its notes. But Atlas was breaking that rule. It was releasing pure nickel vapor, metallic atoms shimmering in the ultraviolet glow, with almost no trace of iron. This wasn't a measurement error. Observations were confirmed by multiple telescopes across the globe, and the ratio was undeniable. Nickel abundance was thousands of times higher than expected. The comet's metallic fingerprint read like a cosmic prank. How can nature separate two elements forged together at birth? The first explanation seemed almost mundane. Maybe Atlas was contaminated by a region of space rich in nickel, poor in iron. But that idea collapsed under the weight of probability. Stars don't create such imbalance easily. It would require conditions so specific that the comet's very existence would be statistically absurd. Another theory proposed that intense radiation, perhaps from the comet's home star, had stripped away lighter metals while leaving the heavier ones behind. Yet even that scenario struggled to explain the scale of difference. Something deeper was at play, something that suggested chemistry under alien laws. To grasp how strange this is, imagine taking a handful of Earth's most common rocks and discovering that half of their atoms had gone missing without reason. In our solar system, comets carry dust rich in silicates, carbon and metals in precise patterns that mirror the chemistry of the early sun. Every particle tells a story about formation, temperature, and cosmic lineage, but Atlas's nickel-heavy vapor rewrites that story entirely. It's as if its parent star formed in a galactic environment where nuclear reactions favoured nickel production, an evolutionary path foreign to our corner of the Milky Way. Scientists began calling it the metal paradox. Nickel without iron shouldn't exist, and yet there it was, shimmering defiantly through ultraviolet sensors. To some, it hinted that Atlas might have been born from a population of ancient stars' massive short-lived suns that burned hotter and faster than ours, leaving behind chemical imprints from an era long before the solar system was born. These stars could have forged unusual metallic ratios, ejecting them into the interstellar medium from which Atlas later condensed. In that sense, the comet might not be simply a wanderer. It might be a fossil, preserving the elemental memory of the early galaxy. Others suggested a more radical explanation. Perhaps nickel wasn't born in its usual way at all. Maybe some internal alchemy was taking place inside the comet right now. When cosmic rays or ultraviolet light strike ices rich in carbon monoxide and cyanide, they can trigger strange reactions. Laboratory simulations show that such energy can rearrange molecular bonds, freeing metallic atoms from compounds and leaving behind a selective metallic vapor. Could Atlas be performing that reaction on a grand scale, powered by sunlight and interstellar radiation? If so, then it's not just a comet, it's a natural chemical reactor, creating exotic compounds that we've never observed outside a laboratory. A few researchers went even further, speculating that the nickel could come from internal heating. Deep inside the comet, radioactive decay of short-lived isotopes might still generate warmth. If Atlas contained tiny fragments of material rich in such isotopes, the residual heat could vaporize certain metals before others, selectively releasing nickel gas. That process would make the comet an ancient battery, discharging its stored cosmic energy after billions of years adrift. As theories multiplied, the nickel signal persisted, steady, undeniable, gleaming like a signature from a forgotten chapter of galactic history. Whatever its origin, this imbalance suggested that the universe isn't chemically uniform after all. Each interstellar visitor could be carrying a unique accent, a dialect of matter shaped by the conditions of its birth. In that sense, studying Atlas isn't just about understanding a comet, it's about decoding the diversity of the galaxy itself. The absence of iron has become a clue, a doorway into questions that challenge the very assumptions of cosmic chemistry. For every scientist staring at the spectral charts, that missing iron line has taken on symbolic weight. It's a reminder that the cosmos hides its complexity in the smallest details. A single element's absence can hint at entirely new pathways of creation. Somewhere in the faint blue glow of Atlas's vapor, nickel atoms drift freely, whispering secrets of long-dead stars. Their light travels millions of kilometers to reach our instruments, carrying evidence of a process that unfolded before the sun was even born. Each photon that strikes a detector is a fragment of that ancient story, a metallic echo from the galaxy's youth. In the end, the question remains suspended in the dark. If this comet can carry nickel without iron, what else might be possible out there? What other rules of cosmic birth and decay might be waiting to be rewritten? The more we look at 3i Atlas, the more it seems to turn science into poetry and certainty into wonder. Something about 3i Atlas feels alive, though every atom of it is ancient ice and dust. It drifts through the dark like a frozen lung, inhaling starlight and exhaling water vapor. When scientists call it active, they mean it's shedding material throwing off gas and dust as it approaches the sun, but with Atlas. That word takes on another layer. Its awakening is not gradual like other comets. One moment it's quiet, a silent rock tumbling in the black, and the next it flares to life as if some invisible hand has flipped a cosmic switch. That's what makes it so unsettling. Comets aren't supposed to behave like machines with an on-off mode. The first signs of this awakening were subtle. Amateur astronomers noticed a faint brightening in March, a shimmer that didn't fit the models. Then, within days, the brightness exploded, growing a coma an enormous halo of gas and dust that expanded faster than calculations could predict. It wasn't sunlight alone. It was as though Atlas had reached a threshold, a point where internal pressure overcame the grip of ice. Something deep inside it had decided to wake up. In normal comets, activity begins as solar heat penetrates the surface, warming the ice and releasing gas that drags dust into space. But Atlas doesn't follow the normal rules. It's too far away for that kind of heating to be efficient. Instead, scientists suspect a buried layer of supervolatile compound substances like carbon monoxide, carbon dioxide, or even nitrogen that vaporize at extremely low temperatures. When these pockets rupture, they create jets powerful enough to blast through the crust, releasing cascades of material all at once. Picture an ancient glacier cracking under sudden pressure, but in this case, the fracture happens in an alien world racing through interstellar space. The images captured by telescopes reveal something even stranger. Its coma isn't uniform, it's asymmetrical, with bright arcs and dark patches that shift over time. It's almost as if Atlas spins with a pulse, exposing vents one by one in rhythmic bursts. Each rotation adds new detail to its changing shape, like a heartbeat recorded across millions of kilometers. This pattern suggests a complex internal structure, a relic of its formation around a distant star. The awakening could be more than just heat and chemistry. It could be memory. Each layer of ice tells a story, frozen in sequence like pages of a book. As the comet warms, it reads its own history aloud, releasing gases in the order they were buried. First come the easy vapors carbon dioxide and cyanides, then water, and maybe, in time, exotic molecules that can't survive anywhere else. Watching Atlas come alive feels like watching a fossil breathe, a ghost reclaiming its form. Astronomers have started calling its flare-ups bursts, and they happen unpredictably. Sometimes the comet brightens by half a magnitude overnight, then dims again as if exhausted. This erratic rhythm defies the clean curves of mathematical prediction. It's chaos sculpted by physics we barely understand. Some compare it to the behavior of comets from the Oort cloud, those distant icy relics that sometimes disintegrate as they enter sunlight for the first time in millions of years. But Atlas isn't from here. It's interstellar, a messenger from a different birthplace entirely. Its chemistry and its awakening might follow rules inherited from another sun's warmth, another world's physics. In that sense, what we see now could be a pattern not of failure, but of adaptation, a survival instinct shaped under alien skies. The most haunting images are those showing its disintegration. In late observations, Atlas began to fragment, breaking into several large pieces. Each fragment glowed with its own jet, as if a single entity was splitting into smaller selves, each continuing the ritual of evaporation. This self-division turns the comet into something mythic, a celestial chrysalis unfolding in space. Some astronomers suggested the fragmentation might be due to rotational stress, the comet spinning too fast for its fragile structure to endure. Others think volatile pressure tore it apart from within. Either way, the process looked like rebirth rather than death, a transformation that released even more gas and dust, amplifying its brightness one last time before it faded into invisibility. Through the telescopes, that fading wasn't a simple dimming. It was poetic, a gradual unravelling of identity. The coma spread thin, the fragments drifted apart, and the once luminous core dissolved into the background of stars. Yet in its death, Atlas taught us more than in its life. It revealed how interstellar ices behave, how alien chemistry resists silence even in deep cold. Its awakening wasn't just physical, it was symbolic of the universe's restlessness. Even after billions of years of drifting in frozen darkness, matter still remembers motion, reaction, and transformation. It's a reminder that dormancy is never eternal. Energy finds its way back, whether in a cell or a comet. For scientists, Atlas's awakening poses both a question and a warning. If a frozen relic can spring to life so violently, how many others are waiting in the void, invisible until their own sudden ignition? How many wanderers are crossing the spaces between stars, carrying traces of worlds long gone, ready to wake the moment they feel a hint of warmth? Atlas's story may have ended, but its message lingers. Nothing in the universe truly sleeps forever. Every silence hides a spark, and every frozen traveller carries within it the memory of fire. Every once in a while, the universe offers us a relic from a time before our sun existed, a silent traveller that carries the memory of stars long dead. Three-Eye Atlas is one such relic. Its orbit tells the story clearly. It isn't bound by the gravity of any world in our system. Its trajectory is hyperbolic, a perfect arc of escape, proof that it came from interstellar space. It has no home here. It is merely passing through, an ancient messenger from beyond the heliosphere. When astronomers traced its path backward, their calculations led far beyond the sun's gravitational influence into the thin dark between stars. Its velocity was too great to belong to any object born in the Oort cloud, the icy boundary of our solar system. Instead, It had wandered through the galaxy for perhaps hundreds of millions, maybe even billions of years, drifting in near absolute zero until gravity from some distant encounter flung it into our neighbourhood. That realization transformed Atlas from a curiosity into a relic of cosmic archaeology. If it truly formed around another star, then every grain of dust, every frozen molecule inside it is a sample of another world's chemistry, a time capsule from a stellar nursery that existed before ours. In a sense, Atlas is older than the Sun. When it was born, our star was still just a swirling cloud of gas waiting to ignite. The atoms within the comet likely condensed in the debris field left behind by a generation of stars that lived and died long before the solar system took shape. Those ancient suns burned hotter, aged faster, and exploded into supernovae that scattered heavy elements, nickel, carbon, oxygen, across the Milky Way. From that cosmic ash, new systems were born. Atlas's parent star may have been one of those firstborn, part of the thick disk population, an older, slower layer of the galaxy that formed before the spiral arms settled into their current shape. The chemical anomalies inside Atlas fit that story. The surplus of nickel, the lack of iron, and the unexpected ratios of carbon dioxide and cyanides could all be fingerprints of a galactic epoch when the rules of stellar nuclear synthesis were slightly different. Studying it is like analysing a fossil from a species of chemistry that no longer exists. To hold a piece of Atlas in a laboratory would be to touch material older than the Sun, older than Earth, perhaps older than life itself. That thought haunts the scientists who follow its trajectory. Because interstellar comets move so fast they are nearly impossible to catch. By the time we detect them, they're already leaving. Atlas's speed, about 30 kilometers per second relative to the Sun, means it spends only a brief moment in our reach before returning to the galactic deep. Yet, for that fleeting window, we can read its light and glimpse the prehistory of our own origins. The data suggests that the galaxy is full of such travellers, fragments of long-lost systems wandering freely. Each one is a messenger from a different cosmic era, a different chemistry lesson. Atlas, with its peculiar metallic composition and volatile activity, is a representative of a time when the universe was still experimenting with the materials that would later build planets. Perhaps this is what makes it so magnetic to the human imagination. It's not just a comet, it's a survivor. It has endured the collapse of stars, the drift between galactic arms, the endless radiation storms of deep space. It has carried its message across unimaginable distances, only to reveal itself briefly before vanishing again. The thought that it might have seen our galaxy evolve, the spiraling arms twisting, the black holes feeding, the nebulae giving birth to new suns, is both humbling and thrilling. It reminds us that time in the universe isn't linear like our lives. It loops and echoes, folding ancient dust into new worlds. In that cycle, Atlas is both ancestor and stranger, both ancient and new. For a moment, we have the privilege of witnessing it, a visitor from the galactic past gliding through our modern sky. The light that glints off its icy surface is a reflection of epochs that existed before human eyes, before the Earth, before even the Sun had a name. Its journey is the story of persistence, of motion without destination. The galaxy is vast, and most travellers like Atlas will never be seen. Yet once in a lifetime one crosses our path, reminding us that the materials we're made of are not local, they are universal. Every breath we take contains atoms that have crossed the same void. Atlas's path, as mapped by astronomers, stretches outward toward the stars again, never to return. Soon it will vanish, its faint trail dissolving into the interstellar dark. But its story will remain etched into data, preserved in memory as a testament that some travellers are older than the worlds they visit. And when it disappears, the space it leaves behind will feel a little emptier, a reminder that the universe keeps its oldest secrets not in words, but in motion. When astronomers first dissected the light of 3I Atlas, they expected to find a chemical signature resembling our own comets, mostly frozen water with traces of carbon monoxide and simple organics. Instead, they found something that looked like it belonged to another universe. The ratios were all wrong. Carbon dioxide dominated where water should have ruled. Cyanide molecules appeared in strange abundance, and traces of complex carbon chains, precursors to amino acids, were hiding in the glow. It was as if the comet's chemistry had evolved in an environment with a completely different balance of elements. a place where oxygen was rare, carbon plentiful, and the laws of volatility played by different rules. This alien recipe stirred a question older than science itself. Could such chemistry carry the seeds of life? Not life as we know it, but the ingredients, the molecules that could, under the right conditions, awaken into biology. Comets have always fascinated scientists for this reason. They are messengers of raw material, icy vaults of primordial compounds preserved since the dawn of star systems. On Earth, many theories of life's origin point back to comets, delivering water and organic molecules during the planet's violent youth. But Atlas complicates that picture. If comets from other stars can carry different chemical patterns, more carbon, less oxygen, more cyanide, fewer silicates, then perhaps every planetary system hosts its own version of the life experiment. Each world could begin with a distinct starter kit, dictated by the chemistry of its parent star. The implications stretch far beyond astronomy. In the ratios of carbon to oxygen, in the faint traces of nitrogen-bearing compounds, we see a cosmic diversity that could mean that life, wherever it arises, wears the flavour of its birthplace. Some scientists call it chemical dialect. Atlas may be speaking one such dialect, its molecular phrases formed in a laboratory light years away. To understand it, researchers have turned to spectrographs, decoding every spike of infrared and ultraviolet data. The results are astonishing. The carbon dioxide to water ratio is among the highest ever recorded. In our solar comets, water dominates by a wide margin. Here, it plays a supporting role. That alone changes everything. Carbon dioxide sublimates much farther from a star than water does, meaning Atlas can stay active even in deep cold. This explains its persistent outgassing at vast distances, but it also hints at a chemistry optimized for the void. Perhaps it was born in a cooler region of its home system, a place where CO2 was plentiful and water scarce, or maybe it formed around a carbon-rich star where oxygen was simply harder to come by. In either case, its molecular blueprint challenges our Earth-centered assumptions about what normal looks like. And then there's the cyanide. Hydrogen cyanide HCN is one of the most reactive molecules in prebiotic chemistry. In controlled conditions, it can form amino acids, nucleobases, and even the building blocks of RNA. It's a molecule with two faces, deadly to living organisms but essential to their birth. The fact that Atlas carries so much of it suggests that interstellar comets could be seeding the galaxy with these precursors wherever they go. Imagine millions of such travellers wandering between stars, dusting young planetary systems with cyanide, carbon chains, and volatile organics, a cosmic distribution network for potential life. This isn't poetic speculation. It's the foundation of the panspermia hypothesis, the idea that the chemistry of life is universal and mobile, drifting between worlds on comets and asteroids. Atlas then becomes more than an object of study. It's a courier, a frozen arc of molecular potential that has crossed interstellar space for eons. Every outburst that sends its gases streaming into the dark is a tiny act of creation, scattering molecules that might someday find a home. For those who study astrobiology, this is electrifying. The diversity of its compounds hints that the galaxy may be filled with millions of different chemical flavors of life. On some worlds, biochemistry might be based on nitrogen cycles instead of carbon. On others, metals like nickel could play roles that iron fills on Earth. The cosmic laboratory is vaster than we ever imagined, and Atlas is one of its mobile experiments. Even its abnormal abundance of nickel might not be coincidence. Metallic elements can act as catalysts, helping molecules reorganize into more complex structures. In that sense, Atlas may carry not just the ingredients for life, but the tools for assembling it. Every molecule it releases into space joins the invisible dust that drifts between stars' dust, that may one day fall into a newborn planet's atmosphere and take part in the same miracle that happened here. Of course, no one is claiming Atlas is alive or that life travelled inside it. What makes it extraordinary is how close its chemistry comes to the threshold, the place where physics ends and biology begins. The comet shows us that the boundary between inert and living is thin, and that the ingredients for crossing it are scattered everywhere. When we look at its spectrum, we're not just seeing gas, we're reading a recipe written in another language, a language older than the sun, carried across the galaxy for billions of years, waiting for someone with the patience to translate it. And perhaps that's the real story behind Atlas, not a tale of alien visitors or cosmic anomalies, but of the universe's relentless tendency to make complexity wherever it can. Given enough time, energy, and motion, even the coldest rock can whisper the first syllables of life. It began with a handful of amateur astronomers staring at faint ripples in radio data signals too weak, too brief, too strange to fit any catalogued phenomenon. They weren't professionals. They were dreamers with backyard dishes, engineers and students scattered across continents, bound together by curiosity and late-night Discord servers. They called themselves the Ghost Hunters, half as a joke, half as a declaration. What they sought were the invisible whispers hidden between stars' bursts of static that might be natural or not. When Atlas entered our skies, it caught their attention instantly. Its orbit, its activity, its timing. All seemed oddly synchronized with a series of circular radio emissions discovered months earlier. The signals weren't beacons, not exactly. They resembled expanding rings of faint radio light, like ripples on a cosmic pond. Professional astronomers had already spotted a few of them and dubbed them odd radio circles, or ORCs. But to the Ghost Hunters, they were more than curiosities, they were invitations. The group began overlaying Atlas's path across the positions of known ORCs, running simulations through open-source sky mapping software. What they found sent a thrill through their forums. One of the rings, barely visible in archived data, intersected precisely with the region where Atlas had first been detected. Coincidence, said most scientists. Statistical noise. But for the Ghost Hunters, it was enough to dig deeper. Their message boards filled with screenshots, coordinates, and hand-drawn hypotheses. What if the comet wasn't merely reflecting sunlight? What if it was interacting with interstellar plasma, triggering electromagnetic echoes we could detect as radio ghosts? It sounded wild, but in science, every revolution begins with an unlikely idea. The group began collecting data from public radio observatories, stacking weak signals and filtering noise. They compared their findings with spectral data from SWIFT, the same telescope that had revealed Atlas's water outbursts. Something strange emerged, a faint correlation between the comet's brightest ultraviolet flares and short, low-frequency pulses in the radio bands. Not proof, but a pattern, something that whispered, "Look closer." Soon, the story spilled beyond the forums. Amateur astronomers wrote blog posts. Small YouTube channels speculated about the Atlas code, and local papers picked up the thread. The Ghost Hunters became minor legends outsiders challenging the ivory tower, chasing mysteries professionals dismissed. And yet, their enthusiasm wasn't misplaced. Historically, citizen scientists have discovered some of the most important cosmic phenomena, novae, comets, even planets. The boundary between expert and enthusiast has always been porous. The night sky belongs to whoever looks up. The Ghost Hunters reminded the world of that. In time, their project evolved into a loose network of data volunteers, teachers, retirees, even a musician who built homemade filters from guitar amplifiers. They didn't have million-dollar instruments, but they had passion and time, the two ingredients professional observatories always lack. Together, they produced one of the largest open-source radio sky maps of the year, revealing not just the ORCs but also faint, ring-like anomalies scattered across the galactic plane. Were they real structures or processing artifacts? No one knew. But their persistence forced established astronomers to pay attention. Soon, major observatories like ASCAP and Meerkat confirmed that the ORCs were indeed real vast circular emissions of radio waves, each hundreds of thousands of light-years wide. They weren't linked to Atlas directly, but their discovery was fueled by the same spirit of collective curiosity that had brought the comet into public fascination. To the Ghost Hunters, that was enough. The ORCs became a symbol of what happens when ordinary people refuse to look away from anomalies, when the boundaries of science stretch just enough to let new voices in. And as Atlas faded from view, the group didn't dissolve, they expanded. They started tracking other interstellar visitors, logging every unexpected blip, every burst, every quiet anomaly the professionals overlooked. Their motto became, "See what shouldn't be seen." Some of their members went on to collaborate with universities, publishing papers under joint credit. Others stayed independent, content to wander the digital frontier, mapping the unseen. In many ways, they became the comet's human reflection, a collective intelligence awakened by curiosity, operating in the shadows of the mainstream. Their search was never about proving alien life or uncovering conspiracies. It was about wonder, about refusing to let mystery fade into indifference. The ghost hunters taught us something profound, that discovery isn't a privilege of the credentialed, but a consequence of attention. The universe hides its most extraordinary truths in plain sight, waiting for someone with patience and obsession to notice the flicker in the data. Atlas came and went, leaving its trail of vapor and questions, but its real legacy may have been this: a generation of stargazers who learned that the act of looking is itself a kind of communication. When the sky whispers, it doesn't care who listens. When Atlas first lit up the sky, it didn't belong to any single nation, institution, or observatory. It belonged to everyone who looked up. Its light crossed continents, oceans, and political boundaries, connecting radio antennas in New Zealand with optical telescopes in Chile and backyard cameras in Poland. That universality became a quiet revolution, proving that science, when unshackled from bureaucracy and ego, thrives as a shared language. The Comet story evolved into something larger than astronomy. It became a case study in how discovery happens when walls fall away. Traditionally, science has drawn lines between amateurs and professionals, between credentialed researchers and citizen observers. But 3i Atlas erased those lines. It arrived in the era of open data, live-streamed observations, and collaborative analysis, where a teenager with a laptop could detect a variation in brightness before an entire research team could process its telescope cue. The comet didn't care who saw it first. It only cared that someone was watching. When the ghost hunters found possible correlations in radio data, professional astronomers initially dismissed them as enthusiastic noise. Yet within months, some of those same scientists were citing the group's data compilations in their reports. That quiet shift acknowledging the value of grassroots observation marks something profound. It showed that curiosity itself, not credentials, is the true currency of discovery. Around the world, amateur astronomers began forming micro-networks, synchronizing their observations through open-source software. Data flowed across borders like starlight, unfiltered by politics. A radio engineer in Turkey cross-referenced emissions with a data analyst in Canada. An astrophotographer in Argentina compared coma expansion rates with a high school student in Japan. Each contribution, however small, added a thread to the collective understanding of this alien traveller. Science without borders isn't utopian, it's practical. In a universe this vast, no single institution can see everything. The democratization of tools, the affordability of sensors, the availability of real-time data, the rise of machine learning, means that the map of the cosmos is being redrawn not by a few, but by thousands. Atlas became the perfect symbol of this new paradigm, a cosmic object too unpredictable for any single agency to control, too fleeting to monopolize. It demanded global attention, and the world responded. There were still tensions, of course. Some professionals grumbled that open collaboration invited misinformation. Others feared that the flood of unverified data would drown serious research. But those same concerns have haunted every technological revolution, from the printing press to the internet. And just like before, the solution wasn't restriction, it was adaptation. Within months of Atlas's discovery, teams began creating hybrid platforms where professional astronomers could vet, verify and amplify amateur findings. Forums became peer-reviewed spaces in miniature, where mentorship replaced gatekeeping. Knowledge, once hoarded in subscription journals, began to flow more freely. This collaboration didn't just advance the study of Atlas, it reshaped how humanity explores the unknown. Some began calling it distributed curiosity. Instead of a few experts pushing the frontier, thousands of independent minds became nodes in a shared network of wonder. Each observer, no matter how small their telescope, became part of a planetary sensor array. And because Atlas's story unfolded in real time online, millions witnessed not just the science, but the process of science, the messy, human, exhilarating dance of doubt and discovery. There's something almost poetic about it, an interstellar comet inspiring an intercontinental consciousness. The same forces that send fragments of matter drifting between stars also drive ideas across digital space. Curiosity, like gravity, pulls minds together. In that sense, Atlas was never just an astronomical event. It was a rehearsal for a new kind of civilization, one where science is participation, not privilege. Even institutions like NASA and the European Southern Observatory began to notice the shift. They started hosting public challenges, inviting coders and hobbyists to help pass telescope data. The line between spectator and scientist blurred further. This merging of worlds, fragile and imperfect though it was, became Atlas's truest legacy. It reminded humanity that knowledge is not a territory to be owned, but a horizon to be shared. Every photon reflected off the comet travelled millions of kilometres before touching a human lens. Every data point recorded was a small act of unity. When seen from that perspective, the differences between professional and amateur, nation and nation, fade into irrelevance. The sky belongs to all of us, and maybe, in this age of division, that realization is its own kind of miracle, that a silent rock from another star could teach a planet how to cooperate. Atlas showed us that discovery doesn't demand uniformity. It demands openness, a willingness to listen, to share, to build meaning together. The comet passed, its tail dissolving into cosmic dust, but the network it inspired endures a constellation of minds, proving that science, at its best, knows no borders. Humans are wired to see patterns, to stitch meaning into randomness. It's how we survive the wild, to notice the rustle in the grass before the predator pounced, to find order in chaos. But in the modern world, that instinct has evolved into something stranger, the urge to connect every anomaly, to turn coincidence into conspiracy and randomness into revelation. The story of Three-Eye Atlas collided head-on with this human quirk. As the comet's behaviour grew more bizarre, its unexpected activity, its spectral oddities, its connection to interstellar space, the online world began weaving its own mythology around it. Suddenly, social media filled with speculation. Atlas wasn't just a comet, it was a message, an omen, a harbinger. The same tools that had empowered citizen scientists now amplified superstition. The line between observation and imagination blurred. Every unusual measurement became a clue, every coincidence a sign. The coincidence effect, as psychologists describe it, is the human tendency to impose causality where none exists, to see intent in accident, design in noise. In the data-driven age, it's stronger than ever. When thousands of eyes are watching the sky, anomalies multiply. One observer sees a burst of light, another halfway across the world records a glitch in their detector. Within hours, social feeds fuse the two into a narrative, a signal, a cover-up, a cosmic event hidden from the public. The comet's mystery fed that hunger perfectly. When the ghost hunters released their open-source radio maps, a handful of users noticed faint patterns resembling coded sequences. A statistical artifact, nothing more, but screenshots spread faster than clarification. Forums buzzed with talk of extraterrestrial communication. Influencers capitalized on the hype, spinning stories about government suppression, galactic visitors, and Project Atlas. In reality, the only project was curiosity itself. Yet in the digital echo chamber, myth always travels faster than measurement. Scientists faced a familiar dilemma. Ignore the noise and misinformation thrives. Engage with it, and you legitimize it. Some tried humor, others posted patient explanations about signal interference, about how radio waves bend and scatter, about the ease of seeing meaning where there is none. But by then, the idea had taken root. Humans crave purpose, and in a universe as vast and indifferent as ours, even a comet can become a mirror for that longing. The coincidence effect doesn't just shape public imagination, it shapes science itself. Many discoveries begin as coincidences, as patterns glimpsed at the edge of chaos. The difference lies in how we test them. Scientists turn coincidences into hypotheses. Conspiracy theorists turn them into conclusions. Atlas became a case study in that divide. Its bizarre chemistry, its unpredictable brightness, its alien trajectory all true, all measurable. But each observation birthed a dozen interpretations, some scientific, some fantastic. One thread claimed the nickel anomaly was proof of engineered material, artificial alloys from another civilization. Another insisted the comet's fragmentation was deliberate, a controlled dispersal of probes. None of it survived scrutiny, but the appeal was undeniable. The unknown always invites projection. To watch the world react to Atlas was to watch the psychology of pattern-making unfold in real time, In a sense, the comet's greatest revelation wasn't about chemistry or physics, it was about us. We are creatures haunted by coincidence, driven to make sense of the senseless. In a sky of infinite randomness, we are storytellers more than observers. And yet, that flaw is also our gift. Without it, we might never have noticed the laws of gravity or the rhythm of orbits. The instinct that births superstition also births science. Both are born from the same yearning to connect the dots. The challenge is learning when to stop connecting. For the astronomers studying Atlas, coincidence became both a trap and a teacher. Patterns that first looked suspicious, a pulse in the radio data, a periodic flicker in brightness, eventually revealed genuine physics. Jets of gas turning on and off as the comet spun, emission lines shifting as fragments separated. In that way, even false leads had value. The key was discipline, testing, eliminating, refining. Science isn't the absence of imagination, it's imagination under control. Meanwhile, outside observatories, Atlas became a social phenomenon. Hashtags trended, podcasts speculated, artists painted it as a green eye watching Earth. The coincidence effect had done its work turning data into narrative, narrative into culture. And maybe that's not entirely bad. In a distracted world, few things still make people look up. For a brief moment, a comet from another star reminded humanity that the sky isn't empty. Whether through reason or myth, people rediscovered awe. The trick, perhaps, is balance. To embrace wonder without surrendering to illusion, to let curiosity thrive without mistaking it for prophecy. In the end, Three-Eye Atlas wasn't an omen or a message. It was a rock, a chemical experiment from a forgotten system. Yet in its fleeting passage, it taught us how easily the human mind turns the random into the meaningful, and how, with patience and humility, meaning can still emerge from coincidence, if we're willing to separate the stories we tell from the truths the universe whispers. It began as a spectacle of progress. A private spaceflight company, Blue Origin, announced a special commemorative launch scheduled just weeks after Three-Eye Atlas reached peak brightness. The mission was modest, a suborbital flight carrying a mix of research payloads and symbolic artifacts, including a small capsule containing meteorite fragments. It was supposed to be a celebration of human curiosity, a gesture of connection between Earth and the vast unknown. Yet within hours of liftoff, the event slipped into silence. The rocket launched successfully, reached its planned altitude, and then, inexplicably, the live feed cut out. No explosion, no error message, just a fade to black. The stream ended mid-transmission, leaving millions of viewers staring at blank screens. Official updates were delayed. The company released a brief statement hours later citing telemetry anomalies and data loss during re-entry. The capsule, they claimed, had landed safely, but the absence of footage fueled immediate speculation. In a world where everything is recorded, the absence of evidence feels louder than evidence itself. The internet erupted. Within minutes, conspiracy threads connected the event to Atlas. They found something up there, one post declared. The signal was real. Others noted that the company's trajectory path crossed the same coordinates, where amateur astronomers had reported a faint radio disturbance days before. It was nonsense, but the timing was irresistible. In the public mind, the comet and the missing data became one story, the flight that vanished into mystery. Scientists, of course, dismissed the link. Data loss during atmospheric re-entry isn't rare. Communication blackouts happen whenever a returning craft ionizes the air around it, creating a plasma barrier that blocks radio signals. But reason rarely satisfies when imagination is involved. The coincidence was too perfect, the silence too cinematic. For days, social media thrived on fragments, blurry screenshots, leaked telemetry charts, alleged insider messages. No one could confirm anything. In truth, the flight had landed safely in the desert, but the company's public relations mishandling turned a routine anomaly into a digital myth. By the time the official footage was released days later, edited and mundane, the narrative had already escaped into folklore. The vanished flight, as it came to be called, became the 21st century echo of the same myth-making instinct that haunted the Atlas story. It wasn't about facts, it was about the hunger for wonder. People wanted the universe to be mysterious, to respond to their curiosity with something more than silence. In that hunger, the simplest technical glitch became a cosmic message. The parallels between Atlas and the missing flight ran deeper than anyone expected. Both were stories about disappearance of signals fading into static, of light dissolving into dark. Both blurred the boundary between science and imagination, and both revealed how fragile truth becomes in an age of instantaneous communication. When everything is visible, absence feels like deception. The flight that vanished became a metaphor. News anchors debated transparency in private space programs. Philosophers wrote essays about modern myth-making, and educators used it as a case study in digital skepticism. Yet underneath all the noise, a quieter truth emerged. Our relationship with technology mirrors our relationship with the cosmos. We crave control, understanding, narrative closure, but the universe rarely provides it. Sometimes it just stops transmitting. In the weeks that followed, the company quietly released the flight's data logs. Nothing unusual was found, no radiation spikes, no foreign signals, no unexplained readings. The capsule had functioned as designed. The incident, once magnified by speculation, shrank back into the mundane fabric of spaceflight. But the myth refused to die. In forums and podcasts, the event remained frozen in ambiguity, retold as evidence that something had happened. The more official explanations appeared, the deeper people dug for hidden meaning. It wasn't deception that kept the story alive, it was longing. Humanity, faced with an indifferent universe, fills its silences with significance. Just as Atlas's water outbursts inspired theories of alien engines, the vanished flight became a stand-in for our fear that we might miss the moment when the cosmos finally speaks back. There's a strange poetry in that. For all our satellites and sensors, we are still creatures who gaze into darkness and wait for answers. The flight didn't vanish. Our understanding did. Its story became a mirror, reflecting the same tension that runs through all exploration, the space between what is known and what is hoped. In the end, 3i Atlas and the vanished flight are threads of the same tapestry, reminders that discovery isn't only about data, but about faith in the process of looking. We keep searching, even when the feed cuts out, because the act of searching defines us. The rocket came down, the comet drifted on, and the silence that followed belonged to everyone who ever dared to look up and wonder what might be hiding beyond the static. When people looked at 3i Atlas, they didn't just see a comet, they saw themselves reflected in it. The universe has a strange way of holding up mirrors to human thought. Every anomaly, every unexplained shimmer in the night sky, becomes a surface onto which we project our fears, hopes, and desires. In that sense, Atlas was never just an interstellar object. It was a canvas for meaning. Its green glow, its unpredictable flares, even its quiet disintegration, all of it echoed the human condition, brief, luminous, unpredictable, and endlessly searching for purpose. We've been using the cosmos as a mirror since the dawn of thought. Ancient civilizations saw gods in the stars. Philosophers saw patterns in planetary motion. Scientists now see equations, models, and data. But the impulse is the same, to find connection in the void. Atlas, with its alien chemistry and impossible behavior, reignited that impulse in a world grown numb to mystery. For a few months, millions of people paused their routines to follow its journey. It didn't matter whether they understood spectroscopy or orbital mechanics. What mattered was that something out there reminded them of how vast and how fragile existence is. The comet became a shared metaphor. For some, it was a sign of cosmic unity, proof that the same materials that built us drift freely between stars. For others, it was a symbol of impermanence, a reminder that beauty can emerge even from dissolution. To artists, it became muse. To philosophers, parable. The scientist looks at Atlas and sees data points, but the poet sees a traveller who burns brightly and vanishes, leaving behind questions instead of answers. The truth is, both are right. The scientific and the symbolic feed each other, just as observation feeds imagination. The universe doesn't resist meaning, it invites it. Every discovery is a mirror, reflecting not just the cosmos, but the consciousness that perceives it. When we describe Atlas as alive, what we really mean is that it triggers something alive in us. Its rhythmic outbursts, its strange persistence, its refusal to obey expectations, all resonate with our sense of defiance against entropy. It's hard not to anthropomorphize it, to feel a kinship with a piece of ancient ice that refuses to be silent. That projection, irrational though it may be, is what makes exploration human. We can measure the universe, but we cannot help but also feel it. The cosmic mirror doesn't just reflect, it reveals. Through it, we see that our fascination with the unknown says more about us than about the stars. We chase comets and catalogue galaxies not because we expect to find ourselves there, but because some part of us already knows we will. The patterns we discover are echoes of our own curiosity, carved into the fabric of space. Atlas's behaviour reminded scientists how limited even the best models can be. It broke assumptions, bent equations, and refused to fit neatly into categories. But instead of discouraging us, it expanded the mirror. If something as small as a comet can challenge our understanding, what else might be waiting to rewrite our perspective? That's the beauty of the unknown. It humbles and enlarges us at once. In the quiet between discoveries, reflection becomes its own kind of exploration. Perhaps that's what the ghost hunters, the professionals and the dreamers all had in common. They weren't just studying the comet. They were studying the act of searching itself. The cosmos, after all, is indifferent. But we are not. We turn that indifference into meaning. We polish it into insight. We make mirrors out of meteors. And in doing so, we become part of the very process we're trying to understand. When Atlas began to fade, people described it as dying. But comets don't die. They transform. Their fragments scatter and seed other worlds. Their dust becomes part of new beginnings. The same can be said of ideas. When fascination fades, it leaves behind particles of thought that form the core of the next question. Every wonder that dissolves gives birth to more wonder. That's how science grows, through curiosity that refuses to stay still. Maybe that's the truest reflection Atlas offered. We are not separate from the cosmos we study. We are expressions of it. The same elements that burn in distant stars pulse in our blood. The same gravity that binds galaxies binds us to the ground. The comet's path is our own, a brief arc through darkness illuminated by curiosity. And if the universe is indeed a mirror, then what it reflects back is both simple and profound. That to look outward is, inevitably, to look within. Think of the galaxy as an immense library where every star, planet, and wandering rock is a page in an ancient book. Some of those pages are pristine, shining with the glow of new creation. Others are tattered and cold, carrying the stains of time. Through Atlas was one such page and excerpt torn from a forgotten volume, drifting between shelves for billions of years until it happened to fall open before us. Its orbit, composition, and behaviour are not just curiosities, they're paragraphs in the ongoing story of the Milky Way. To study it is to read across epochs, to trace the sentences written by stars long gone. Astronomers sometimes describe comets as archives of formation, time capsules preserving the conditions of their birth. In Atlas's case, that metaphor becomes almost literal. Its ices contain isotopic ratios, tiny imbalances of atoms that encode the environment in which it formed. Those ratios tell of temperatures lower than any our solar nebula experienced, of radiation fields shaped by different stars, of chemistry sculpted under alien rules. In that sense, Atlas is a document written in molecular script, its ink composed of carbon chains and nickel vapor, its language one of spectral lines. When scientists point their instruments at it, they aren't just gathering data, they're translating history. Each photon captured from the comet's coma carries a timestamp billions of years old. The hydrogen atoms released from its water once cycled through another star's atmosphere. The carbon it sheds may have formed in the corpse of a supernova, before being swept into a new protoplanetary disk. Atlas isn't merely an object, it's a witness. The galaxy recycles itself endlessly, and in these interstellar travellers we glimpse the continuity of that cycle, the way dust becomes worlds, worlds become dust, and the story repeats. But unlike books, these cosmic archives are ephemeral. They degrade as they travel. Radiation alters their chemistry, collisions scar their surfaces, and each close pass to a star erases another line of the original text. By the time Atlas reached us, it had already lost chapters. Its fragments were fading punctuation marks in a story that once stretched across light years. And yet, even in its decay, it told us something priceless, that memory in the universe doesn't vanish, it transforms. The molecules that escaped its surface now drift freely, carrying pieces of its record into the interstellar medium, where they will someday join new systems. The archive is never closed, it's constantly rewritten. Humans have always been archivists of the cosmos, cataloguing every flicker of light, every spectral anomaly, every faint echo that crosses our instruments. But Atlas reminded us that we are also part of that archive. The data we gather, the stories we tell, the very act of naming a comet after our instruments, all of it becomes part of the galactic record. When future civilizations scan the sky, they may find traces of our transmissions embedded in the background noise, just as we find traces of ancient stars embedded in a comet's tail. The archive writes both ways. It's easy to forget that the universe is not static. We often imagine it as a backdrop, a stage upon which events occur. But in truth, it is dynamic and alive with memory. Every collision, every burst of radiation, every wandering comet adds another line to the cosmic chronicle. Atlas's strange chemistry, its nickel without iron, its surplus of carbon dioxide, its erratic brightness, are marginalia in that record, notes scrawled by nature in the margins of existence. For scientists, decoding them is an act of both logic and imagination. You can't read the galaxy without dreaming a little. The notion of a galactic archive isn't just poetic, it's practical. Data from comets like Atlas help us reconstruct the timeline of stellar evolution, mapping how elements migrate and how planetary systems inherit the fingerprints of their ancestors. In this way, each interstellar object becomes a clue in a vast puzzle, revealing how the Milky Way sustains its own form of memory across billions of years. When you look up at the night sky, you're not just seeing stars, you're seeing the visible portion of that library. Most of it remains unreadable, hidden between wavelengths, written in languages we've yet to decipher. But every once in a while, something like Atlas drifts close enough to lend us a page. We read what we can before it slips back into the dark. There's a quiet beauty in that fleeting exchange. We can't hold on to the comet any more than we can hold on to time, but we can learn from its brief passage. It reminds us that even in the coldest parts of the universe, information persists. Matter remembers. Light carries memory forward. In a galaxy of endless erasure, the act of remembering even for a moment is sacred. Perhaps that's what Three-Eye Atlas truly represents, the persistence of story in a cosmos that refuses to forget. Nickel is not just a metal, it's a fingerprint, a trace of the galaxy's memory etched into matter. When scientists looked at Three-Eye Atlas and saw the spectral gleam of nickel unaccompanied by iron, they weren't merely measuring composition, they were reading a signature left by time itself. Every atom of nickel in that comet tells a story about the star that forged it. In the heart of massive suns, nickel and iron are born together through nuclear fusion, their atomic structures intertwined in cosmic symmetry. When those stars explode, they scatter their metallic hearts into space, seeding new generations of worlds. But Atlas's nickel doesn't fit that pattern. It stands alone, abundant and unbalanced, a solitary witness to a different kind of stellar history. This imbalance is more than a curiosity. It's a clue that Atlas may hail from a galactic region older and stranger than ours. To understand why, we must think of the Milky Way not as a single, uniform system, but as a living ecosystem of stars, each with its own chemistry and rhythm. The thick disk, a vast layer of ancient suns orbiting above and below the galactic plane, is home to stars forged in the Milky Way's early, turbulent youth. They burned fast, enriched space unevenly, and left behind materials that defy the proportions we now take for granted. In that environment, it's plausible that a comet could form from dust clouds where nickel dominated and iron lagged behind a signature of ancient stellar processes no longer active today. Atlas may therefore carry within it the metallurgical DNA of a time before the Sun, a sample from the galaxy's formative years. In a sense, it's an artifact of stellar evolution, a metallic relic preserved in ice. For astronomers, that makes nickel not just a clue, but a language. By comparing isotopic ratios of nickel to those of other elements, scientists can infer the age and origin of the material, reconstructing the genealogy of stars. The abundance of nickel in Atlas suggests exposure to a high-temperature environment, followed by rapid cooling, perhaps near the shock wave of a supernova that ejected the material into space before it could fully equilibrate with iron. Over time, gravity gathered this uneven dust into a protoplanetary disk around a newborn star, where ice is condensed around metallic grains. Billions of years later, the star died, the system scattered, and Atlas was cast adrift, an emissary carrying within it the memory of that early forge. This idea turns the comet into something more profound than a visitor. It becomes a courier of the galaxy's autobiography. Each nickel atom is a timestamp, a data point in the ongoing cycle of creation and decay. The same metal that forms the core of planets and the alloy of human technology also glimmers in the breath of an interstellar wanderer. It ties us to the stars in literal chemistry. Our coins, our machines, even the steel in our cities, all trace their ancestry to processes that 3i Atlas still embodies. To hold a sample of that comet, were it ever possible, would be to hold a fragment of cosmic history untouched by the sun's influence. Some scientists describe the abundance of nickel as the galactic signature of heavy element recycling, a way to track how the Milky Way evolves chemically over time. Each region of the galaxy has its own accent, defined by the elements its stars produce most efficiently. The inner disk favours iron and silicon, the outer regions carbon and oxygen. But nickel, especially unpaired nickel, belongs to the old voices, the thick disk stars that sang before our spiral arms were born. That makes Atlas a kind of linguistic artifact in the galactic conversation, speaking a dialect no longer native to our part of the sky. In studying it, we glimpse how diversity in stellar chemistry has shaped the evolution of everything that exists, from nebulae to living tissue. Nickel's presence also hints at a more subtle truth, that matter itself records experience. Every atomic ratio is a memory of temperature, pressure, and radiation, a chemical diary written in elemental code. When we analyze Atlas, we're not just identifying materials, we're reconstructing moments of creation. The ratios are coordinates, and together they map the genealogy of matter across cosmic time. There's poetry in that precision. The scientist's spectrograph and the poet's metaphor both chase the same revelation, that the smallest fragment can contain the entire story. Nickel, gleaming quietly in Atlas's vapour, is a symbol of endurance. Long after stars die and comets crumble, these atoms persist, travelling from one system to another, carrying the universe's oldest memories. They are the archivists of existence, indifferent yet eloquent, speaking across light years in the only language that never fades: composition. As Atlas drifts farther from the sun, its spectral lines grow fainter, its voice quieter. But in that fading light, we still hear the echo of the galaxy's early fire, the hum of stellar furnaces that once burned with unimaginable heat. The comet's nickel tells us that creation is not a singular event, but a conversation across time, each generation of matter whispering to the next. To study it is to listen to the universe remembering itself. For centuries, humans assumed our solar system was an isolated bubble, an island of planets and comets, orbiting a single star surrounded by emptiness. The discovery of 3i Atlas shattered that illusion. Its arrival hinted at something staggering. The galaxy may be teeming with billions of interstellar objects drifting silently between stars, unseen and uncounted. Astronomers call them ISO interstellar objects, and they may outnumber the visible stars themselves. Atlas was only the third we've ever detected, but its path suggested it wasn't unique. It was part of a hidden population, a galactic diaspora of fragments cast off by dying systems, remnants of worlds that once circled other suns. Each one could carry a record of its birthplace frozen chemistry, mineral patterns, isotopic quirks that tell the story of an alien solar system. Imagine the Milky Way as a vast ocean and our star system as a small harbour. Every so often, driftwood washes ashore, fragments from distant shores, weathered by time, carrying the faint scent of another world. Most drift past unnoticed, invisible to our telescopes, but occasionally one catches the light just long enough to be seen, and for a fleeting moment we realise the ocean is alive with motion. Detecting such wanderers is nearly impossible. They move fast, reflect little light, and appear without warning. By the time we notice one, it's already leaving. Our first visitor, Oumuamua, was a narrow, tumbling mystery that defied classification. The second, 2i Borisov, behaved more like a typical comet. And then came Atlas, breaking all rules, chemically alien, behaviourally erratic, luminous in defiance of distance. 3 examples, 3 contradictions. Yet from these few, scientists began to extrapolate. If even one ISO passes through the inner solar system every few years, then statistically there must be countless others crossing the outer regions at any given time. They are the galaxy's orphans, wandering without homes, carrying the materials of creation across the void. Some may have been born from shattered planets, others from failed stars. A few might even be planetary embryos ejected before they could grow. They drift for billions of years, exchanging nothing but light. To think about them is to realize that our system isn't a closed ecosystem. It's part of an interstellar web of exchange. Every ejected fragment from a distant sun becomes a messenger, a traveller, a bridge between worlds. Perhaps the very materials that built Earth once came from such a visitor. And perhaps the dust of our own system will someday seed another. The idea transforms the galaxy from a cold vacuum into a living circulation, a network of exchange that makes isolation an illusion. Detecting this hidden population has now become one of astronomy's grand challenges. New survey telescopes like the Vera Rubin Observatory in Chile are designed to catch faint, fast-moving objects with unprecedented sensitivity. Its wide-field camera will scan the entire southern sky every few nights, capable of spotting interstellar visitors weeks before they reach perihelion. Future missions may even chase them directly. NASA has already drafted concepts for interstellar interceptor spacecraft probes that can launch on standby and slingshot toward any ISO that enters the solar system. The dream is to meet one in space, sample it, and finally touch material that predates our sun. Imagine what it would mean to hold a piece of another star's planetary debris, a rock that formed under an alien sky, older than the solar wind itself. Each discovery would be a data point in the Milky Way's grand census, an entry in the ledger of cosmic exchange. And yet the hidden population remains elusive, silent. It moves through the dark like ghosts, visible only when illuminated by chance geometry. For every atlas we detect, millions more drift unseen, their paths never crossing our instruments. Perhaps that's why each discovery feels sacred, a reminder of how much escapes us. The universe is not empty. It is overflowing with travellers we haven't yet learned to see. There's a strange comfort in that thought. It means the galaxy isn't static but restless, filled with motion and memory. Every interstellar object that passes through our system is proof that stars and their worlds are not isolated fates. They are participants in a shared evolution. Matter migrates, connects, and transforms. What we call space is not separation, but the medium through which everything exchanges identity. In a way, the hidden population mirrors our own migrations, our search for meaning across the unknown. We send our probes outward, our signals across the radio spectrum, our curiosity into the dark. They drift, as Atlas does, carrying fragments of us, our chemistry, our questions, our hope. Perhaps somewhere, around another star, another civilization is watching their own comet, wondering if it too came from elsewhere, wondering if it carries the signature of minds that once looked up and wondered the same. The galaxy is a network of travellers, seen and unseen, known and unknowing, bound by gravity and curiosity alike. Atlas was one, briefly visible in our sky, a single word from a cosmic language still being written. Every generation believes it understands the sky until it doesn't. The heavens have always promised stability. Planets move predictably, stars keep their rhythm, and comets follow familiar paths. But lately the sky has been breaking its own rules. Telescopes are recording flares that shouldn't exist, stars that dim and brighten as if blinking in code, and radio bursts that repeat with eerie precision. 3i Atlas was one piece of that pattern, a messenger from beyond the expected, an omen not of doom, but of change. Its strange chemistry, its self-destruction, its inexplicable vitality, all fit into a growing sense that the cosmos is behaving differently than we thought. The illusion of cosmic order is giving way to a deeper truth. The universe is not stable. It is restless. Astronomers have a name for this new era of surprise, the age of transient phenomena. It began quietly with the discovery of fast radio bursts, mysterious pulses of energy from distant galaxies that flash and vanish in milliseconds. Then came the dimming of Tabby's star, a stellar flicker so strange that even seasoned scientists whispered about alien megastructures before settling on dust. We've seen rogue planets drifting without stars, gamma-ray bursts from collapsing magnetars, and supernovae that refuse to fade on schedule. Every few months, something new misbehaves. 3i Atlas fit perfectly into that orchestra of unpredictability. It was a comet that burned like a living thing, releasing water far too far from sunlight, its brightness pulsing as if synced to some hidden metronome. It wasn't an isolated incident, it was part of a pattern, a cosmic mood swing. The more precisely we measure the sky, the more it rebels against precision. Instruments built to confirm theory now deliver astonishment instead. In the past, science advanced through consistency. Now it advances through anomaly. We used to trust the sky to be a backdrop for our stories. Now it's a character with its own will. The cause isn't supernatural, of course. It's observational evolution. We are simply seeing more, faster, and deeper than ever before. Our telescopes never blink. Our satellites monitor light across every wavelength, catching cosmic events that used to unfold unseen. But while the explanations grow more rational, the effect on the human imagination is the same as it was thousands of years ago, wonder mixed with unease. The sky was supposed to be our constant. When it wavers, so does our sense of order. For some, this unpredictability feels threatening. In a world already defined by changed climate shifts, social upheavals, digital noise, the last thing people want is a capricious cosmos. Yet perhaps that's exactly what we need, a reminder that control is an illusion. The universe is dynamic because it is alive in its own way. Atlas's disintegration was not a failure of nature but a performance of it, a visual essay in impermanence. Its fragments, scattering through the void, joined the same cosmic current that carries dust between stars and atoms between lifetimes. The misbehavior of the sky is in truth the creativity of physics unfolding beyond our comprehension. For scientists, each deviation is an opportunity. Every unexpected flare is a message written in light, every anomaly a question the universe poses to itself. The technology we build to chase these mysteries, the radio arrays, the infrared observatories, the AI algorithms scanning millions of data points, has become a new form of perception, an extension of the human nervous system into the stars. We are no longer passive observers. We are participants in a dialogue of discovery. Still, there's something deeply emotional about watching the familiar turn strange. When a comet glows too bright or a star disappears, it stirs the ancient part of us that once read omens in the heavens. Rationally, we know it's data. Instinctively, we feel its prophecy. Atlas reminded us that these instincts coexist, that awe and analysis are twin responses to the same phenomenon. The sky's unpredictability humbles us in an age that pretends to know everything. It reminds us that we are still apprentices in a universe that refuses to stay still. Perhaps that's the real meaning of when the sky misbehaves. It's not rebellion, but revelation. Each inconsistency is a doorway to new understanding, each rupture in order a glimpse of deeper order beneath. The universe isn't broken, it's speaking a dialect we've only just begun to learn. And maybe that's why people looked at Atlas and felt both wonder and melancholy. It was a messenger of chaos, yes, but also of continuity. A reminder that what we call misbehavior is often the first step of evolution. The cosmos, like us, experiments. It tries, fails, transforms, and tries again. When the sky misbehaves, it's not losing its mind. It's showing us that creation is still happening, that even after 14 billion years, the universe has not grown old, predictable, or dull. It is still wild, still writing, still alive. Long after 3i Atlas faded from the sky, its story lingered not in the data archives or research papers, but in the quiet hum of human imagination. Something about that frozen traveller from another star had awakened an ancient instinct in us. The need to wonder, to reach, to ask questions that have no easy answers. It's the same spark that drove our ancestors to light fires in the dark and name constellations after their dreams. The same curiosity that sent probes into the void and built telescopes to peer across time itself. Atlas reminded us that this spark still burns, fragile yet unextinguished. We may have traded myth for mathematics, but the impulse is the same. We seek meaning in the stars not because we expect them to speak, but because we can't bear their silence. Every observation, every charted orbit, every faint signal we decode is a way of saying, we are here and we are listening. The comet's journey was, in a way, our reflection, a brief illumination in an otherwise indifferent cosmos. It travelled for billions of years, carrying the chemistry of a forgotten sun, only to brush against our world for a heartbeat before vanishing again. And yet that moment changed us. For scientists, it expanded the boundaries of known chemistry. For dreamers, it rekindled the sense that the universe is still capable of surprise. For everyone watching, it proved that even in the vast machinery of space there remains room for wonder. The human spark is that refusal to stop being astonished. It's the force that turns data into discovery and mystery into meaning. When Atlas exhaled water where no water should exist, we didn't look away, we built new theories. When it defied physics, we sharpened our tools. When it disintegrated, we kept watching. That persistence, that relentless curiosity, is what defines us. Not our technology, not our knowledge, but our hunger to understand the unknown. Even our errors, our leaps of imagination, are part of the same flame. The ghost hunters staring at radiostatic, the scientists decoding spectra, the artist painting its ghostly trail. All of them were answering the same quiet call that has guided humanity since the first spark leapt from stone. To be human is to look into darkness and invent light. Atlas's passing also served as a kind of parable for our place in time. Just as it wandered from a forgotten system, we too are travellers, brief visitors in a vast story that began long before us and will continue long after. Yet in our short moment here, we can observe, interpret, and connect. We can send messages, launch machines, and write poems that cross generations. Our spark gives the universe a way to see itself. Every question we ask about comets, life, or the origins of matter is the cosmos thinking aloud through us. When we looked at Atlas, it was as though two forms of awareness brushed past each other, one human and fleeting, one cosmic and eternal. That encounter, even unspoken, left an imprint. Long after the comet vanished beyond telescopic reach, its lessons remained etched in equations, in essays, in memories. It taught us that the universe doesn't need to be alive to inspire life, that even the coldest rock can awaken emotion, and that knowledge and wonder are not opposites but allies. In its wake, the community it inspired, scientists, amateurs, storytellers continued to collaborate, driven by the same spark that first made them look up. They understood now that the greatest discoveries aren't just about the objects we find, but the connections we forge in finding them. The human spark is contagious. It passes from one curious mind to another, igniting entire generations. It outlives comets, civilizations, even stars. One day our descendants may watch another interstellar wanderer and recall how their ancestors once traced the path of Atlas through the void. They may wonder about us as we wonder about it, tiny, determined creatures who stared into the infinite and dared to interpret it. In the end, Three-Eye Atlas was not a revelation or a warning. It was a reminder. The universe does not speak in words, yet it answers those who listen. Its language is written in spectra, in orbits, in the faint glow of distant ice. And through the act of listening we make ourselves part of that conversation. That is the essence of the human spark, not certainty, but curiosity, not control, but connection. The spark that turns a question into a bridge between worlds. The spark that whispers, even in the face of silence, look again,